Hi, today we're going to talk about the surface area and volume of spheres. One question for you to ponder is, why do you think the surface area is sometimes larger than the volume? It's an interesting question. So a sphere is a basketball, a baseball, a volleyball, an orange. All sorts of spheres live around us all the time. Grapes are wonderful. And like all our other geometric shapes that we've dealt with this year, a sphere has lots of vocabulary, has some vocabulary associated with it. A sphere has a section inside it that actually goes through the diameter that's called a great circle. So if you hear somebody refer to the great circle, that's what it would be. Because we have a great circle inside of our sphere, this circle has a radius. A radius of a sphere goes from the center to any point on the edge of the sphere. And because I've already talked about it, I'll go ahead and fill this in. It does have a center. And a center would be equidistant from all parts of the sphere. There are some unusual and kind of wild-looking formulas associated with spheres. A sphere has a surface area that can be found by taking 4 times pi times the radius squared. And volume of a sphere can be calculated by taking 4/3 of that pi times radius cubed. And it's really important to remember that you're cubing the radius when the volume. Okay, let's look at an example. I went ahead and got a head start on it. Please forgive me. Drawing a great circle inside of a circle is not my strength. I did the best I can, but it's kind of wonky, let's be honest. This sphere, or this problem, tells me that the diameter of my great circle is 36 centimeters, and it's asking us to find the surface area and volume. Well, I did the real quick calculation to determine what the radius was. And the radius in this case will be 18 centimeters because your diameter is 2 times your radius. Given that, we have enough information to find the surface area. So the surface area of my sphere, I'm going to go ahead and write the formula, is 4 pi times my radius squared. And this is nice and friendly. It only requires me to substitute in one numeric value from my problem, which is 18. And then I'm going to square that. What you'll find is with spheres, sometimes the numbers are rather large. Of course, it doesn't help that we gave you a radius of 18. When I simplify this 4 pi times 324, it gives me a humongo number of 1296 pi. And so that is my surface area, 96 pi centimeter squared. To find my volume, I'm going to use the other formula that we were given. I am if my paper will hold still. Volume is equal to 4/3 pi times my radius cubed. And I'm going to be careful with that. Sometimes it's convenient when solving problems like this to keep the 4 in the numerator with my other terms. I'm going to do 18 cubed. I'm going to put this 3 as a denominator under everything. That'll make my simplification sometimes a little bit easier. 4 pi and 18 cubed is actually a pretty big number. I can read my own handwriting. 5,832, all divided by 3. And when I simplify that, I end up with 7,776 pi. Again, big number, 7. And when I write my volume expression, I want to remember that it's units cubed. So that was a pretty straightforward problem. Let's do one that's more interesting. Okay, let's look at example 2. A sphere has a volume of 4,000 pi divided by 3 feet. Find the surface area. All right, we're going to have to work backwards on this. To find the surface area, I need to know the radius. I wasn't given the radius, so I'm going to have to use my volume to help me find the radius. Right? So let's write down what our volume formula is. It's 4/3. Again, I'm put the 3 in the denominator just to make our life more interesting. 4/3 pi r cubed divided by 3. And I'm going to substitute in what I do know, in this case, that there's 4,000 pi is equal to 4 pi r cubed over 3. I'm going to multiply both sides by 3 to get rid of that variable. And now I can simplify by dividing both sides by 4 pi. Finish this over here. And when I divide both sides by 4 pi, this is not 1200 because I forgot the denominator up here. Silly me. Ugh. We're going to put a 4 there and scribble that out. 4,000 divided by 4. My apologies, guys. 4,000 divided by 4 is just going to be 100. The pi's are going to cancel. And so I have 100 equals my radius cubed. This is 1,000. I'm a mess today. 1,000 equals radius cubed. And so when I simplify, I end up by taking the cube root of both sides with a radius of 10. That was a struggle. But now that I have the radius, I can find my surface area. It's important to write your formulas correctly. Good grief. 4 pi radius squared. The 4 and the pi are constants. My radius that we just calculated was 10, and I'm going to square it. 10 squared is 100. And 4 times 100, 400 pi feet squared is my surface area for this particular sphere. Example 3, we're going to do something similar. We're given the surface area. We're going to work backwards to find the radius. And from there, we can find the volume as the problem's asking for. And example 4 is actually a lot like example 1, so we'll skip that one for today. Hope you've enjoyed.